This question states if a variable resistance is connected to a cell of constant EMF, then which one of the following graphs represent the relation between current I and resistance R? Recall that I is equal to V by R for a cell of negligible internal resistance. So clearly I is inversely proportional to R, which means that as the resistance increases, current decreases. So therefore obviously the option D is correct, right? Also, even if there was internal resistance, I would have written I is equal to E upon R plus R. Still then, as R increases, as small r, that is internal resistance is constant, current will decrease with increase of resistance. Furthermore, here is some information that's related to this, that if we were asked to plot a graph of variation of E with resistance R, EMF, this is purely the EMF here. If it was EMF versus resistance, then it doesn't vary. EMF of the cell is constant. If we are asked to plot variation of terminal potential difference, variation of terminal PD, that is V, with resistance R, right? Then we know that V is equal to E upon R plus R into capital R. This expression can be written as E upon 1 plus R by R. Now notice one thing, that from this expression as R increases, this expression decreases, therefore V increases. But when R becomes very large, V approaches at the maximum E. It cannot increase infinitely. So again, repeating, as R increases, R by R decreases, therefore V increases. That is, when R becomes very large, V approaches EMF E. So the variation of terminal potential difference against the resistance R, external resistance R, shall be of this nature, where it just begins to approach the EMF E. So you should keep in mind that V against R is a graph which is a curved nature, whereas E versus R is a straight line, and I versus R, which was the nature of the question, is obviously something like a hyperbola, rectangular hyperbola, or very close to it.